Okay, so now you're going to take a look at the polynomial application problems. You are going to go back and complete 1, 2, 7, and 8 at the end of this video. And I'm going to do the middle ones, 3 through 6. So you're going to come back and do 1 and 2. May need a graphing calculator for those. Should have one of those on your Chromebooks. If not, right at the top of Google Classroom, there's a link. All right, so example 3. At the ruins of Caesarea, archaeologists discovered a huge hydraulic concrete block. It has a volume of 945 cubic meters. The block's dimensions are x high by 12x minus 15 meters long by 12x minus 21 meters wide. What is the height of the block? The total volume is 945. So didn't I just create a polynomial function? I want to know when the volume is 945, and if I can figure that out, I'll know what x is, and x is the height. So I want to show you, you could spend the time multiplying this all out into standard form. That's not going to help you solve this equation because we can't solve a cubic right now. So what I'm going to have you do is take a look at your graphing calculator. If you have to solve for a polynomial function to be a certain amount, here is a good strategy. Why is this? There we go. Okay, it was too dark. Okay, so in your y equals menu, make sure these plot 1s and 2s are not on. So in y1, I'm going to do x times 12x minus 15 times 12x minus 21. And in y2, I'm going to do a horizontal line at 945. Now, if I just hit zoom 6, I'm not going to see much of this graph because it's only a 10 by 10 viewing window. I want to see up at 945. So I'm going to adjust my window so that my y maximum goes all the way up to 1,000. So now hopefully I'll be able to see the intersection point here. So to calculate the intersection point, you can go to second trace, which is the calculate button. You want to find the intersection point of the red and the blue. So I'm going to go over to the first curve being blue, enter, red, enter, best guess, enter. So it says at 3, when x is 3, the height will be 945. Did everyone see at the very bottom there, it says 3, comma 945 is the intersection. All right, this one, they've given you the polynomial function. You again need to solve for this length. So this is a little bit different. We've got variables and variables. So I can't just plug these equations in because I'm not solving for a specific number like up here. So what you're going to do is division. You're going to take these, multiply them together, and divide the original function by your height and your width to get your length. So let's FOIL these out. X plus 2 times x plus 4. X squared plus 2x and 4x. 6x plus 8. So I'm actually taking this function and dividing by that function, and whatever I have left is going to be my length. X squared plus 6x plus 8. So I'm trying to get 2x cubed inside my box. So 2x must have to go in my quotient. 2x times 6x is 12x squared and then 16x. I'm trying to get 17x squared, so I'm missing 5x squared. So that puts 5 up in my quotient, and I hope I get no remainder here. So I get 30x plus 40. Well, that is 46x and the 40 that I'm looking for. So there's no remainder. My length must be 2x plus 5 as the final answer. Number 5. Profit in millions of dollars for a t-shirt manufacturer can be modeled by profit equals this. X is the number of t-shirts produced in millions. Currently, the company produces 4 million t-shirts and makes a profit of $4 million. What lesser number of t-shirts could the company produce and still make the same profit? So again, we're going to plug this into our y equals menu and this into y2 as a horizontal line. We want to figure out another intersection point on the graph. Negative x raised to the third power plus 4x squared plus x 4 million. All right. I'm just going to go to my table first and see if it actually is going to spit out. X is the number of t-shirts in millions. I just want to go to my table 1 through 10 first. Yeah, so 4e to the 6th. So that's a really big number, 4 million. Sorry, I had to delete the horizontal line at 4 million because it was confusing me. So back in the table, I don't need to know where they intersect because the y values that are produced here, can you see 2 areas where it's 4 million? So this is in my table of values. I plugged the function and I just went to the table of values. So this says when I produced 1 million t-shirts, I make $4 million. When I do 4 million t-shirts, I make $4 million. They just want to know what lesser number of t-shirts could they produce, so they could do 1 million t-shirts instead and still produce $4 million. All right, and the last one I'm going to do with you is number 6, and then I'd like you to do some problem solving on 1, 2, 7, and 8. MP3 players. The profit for a manufacturer can be modeled by this function. X is the number of the players produced. Currently, they produce 3 million and make a profit of 48 million. What lesser number of MP3 players could they produce? So let's again put our function negative 4x cubed plus 12x squared plus 16x in our calculator and just look at the table. So can you see 48 million as the solution for both 2 and 3? So it says currently they produce 3 million, but they could actually produce 2 million and still make the same profit. All right, so you are going to try the other 4 problems, 1, 2, 7, and 8, and submit your work on Google Classroom.